Hello everyone, welcome to Ekeeda platform, and this is Ravindra here, your electrical faculty. In this video, I'm going to talk about the problems related with the AC transmission system. And in this, I'm going to cover the technical problems which is used to compare the AC and the DC system here. Okay, in the technical performance, when I have covered the comparison of AC transmission and the DC transmission system. Then I have already talked about the technical performance, in which I have already talked about your voltage profile, your stability. Okay, the line compensation is one of the topic which I am discussing here. The problems of AC transmission system. Okay, so look at here. If I'm talking about the comparison, okay, if I'm comparing the high voltage direct current transmission with high voltage AC transmission, then as per the technical performance, the compensation, or you can say the line compensation, is important one for comparing that. Now, in the line compensation, what is the line compensation? In the line compensation, we have the series compensation techniques and the shunt compensation techniques, so that the power carrying capability can be improved or can be controlled by those parameters. Okay, now look at here. I'm going to talk about some other basic or important points. Okay, in the AC system, in the AC transmission system, we have the options. One is the series compensation technique, and another is shunt compensation technique. Okay guys, so one is the series compensation technique, another is your shunt compensation technique. Now these are the 2 points. In the series compensation, we generally use the capacitor in series. Likewise this. In you can say in the power system, the large number of inductors and the capacitors are present. Okay, in that, for the carrying, if you have to determine the power carrying capability, then you use the reactances. And for improving that power carrying capability, you have to use the capacitors in series, and that is actually called the series compensation technique. So this is the inductor, and in between them I'm adding one capacitor here. Due to this is L, this is L. Net reactance will reduce. As the reactance will reduce, then the power carrying capability will increase. I will explain in the upcoming points. Okay, so the series compensation technique, and this is the shunt compensation techniques, in which the reactances were used. Now this is the AC system. So in the AC transmission system, we have used the series compensation technique and the shunt compensation technique for the long distances. But why this is used? Okay, now this is the main point we have to consider, because there are the problems related with you can say the charging line current, and the voltage drops. Okay, so you have the charging line current and the voltage drops, and due to which the stability decreases. Okay, so stability decreases. That's why we are using the line series compensation technique and the shunt compensation technique. Okay, in this series compensation technique we are using the capacitors. Now I'm adding the next point. Okay, so what is the series compensation technique? Series compensation technique. So what is the series compensation technique? The capacitors are used in series with the line reactances. Okay, so capacitor, that I have already explained, but I'm adding this point for your convenience. Okay, so it's a series compensation technique. This is the series compensation technique. Now look at the other point. Now this, we know that the power carrying capability carrying capability. Okay, I think you know that the power carrying capability, what is the power carrying capability? That is represented by the P, and which is actually Vs Vr, the sine delta upon reactance XL. Okay, by using the capacitor, the total reactance will decrease, because due to this capacitor, the capacitive reactance is called the Xc. Okay, when we add in this, it is actually minus j 1 upon minus j omega c, minus j upon omega c. So due to this negative, so XL will decrease, the total reactance will decrease. As the total reactance will decrease, the power carrying capability will increase. Okay guys, now next point. In the AC system, in the AC transmission system, the necessary to provide the shunt compensation. But why shunt compensation? So it is necessary to provide the shunt compensation. And also I'm adding this point. Okay, but regular intervals, but at the regular intervals. Okay, but at the regular. Now to maintain, I can write, to maintain the constant voltage profile, constant voltage magnitude or profile, I can write once again the profile magnitude by varying the shunt compensation or shunt capacitor or inductor compensation, or you can write shunt impedance. Okay, so I have already talked about the series compensation, and now this is the shunt compensation. So remember one thing, the shunt compensation is actually used at the regular intervals. So at some particular distance, if you are considering the 100-kilometer transmission line, then according to that we calculate, and according to the calculations we will come to a point that at every 20 kilometer we have to use the regular shunt compensation, or you can say shunt impedances, to maintain the constant voltage profile, because the voltage should be constant. It should not be that much variation. There should not be that much variation. Okay, now next point. Now look at that. If I talk about the AC ties, okay, so what is AC ties? What is the AC ties? AC ties, what it does, suppose there is a two power systems. to neighboring power system. Power system, it means it has the generating station, distributing station, and the transmission towers or transmission system, you can say, from generating to the load side. So this is the one power system, and this is another power system in nearby city. So these are connected with the AC ties lines. It is actually beneficial, but at the same time there is a problematic condition may arise due to the disturbances, and which I'm going to explain and write here. The AC ties. What are the AC ties? Look at here. These are AC ties. AC ties are used to connect used to connect the two power systems system and automated generation automated generation control of both system can be coordinated. Most important. Okay, coordinated. So let us suppose this is the power system 1, this is the power system 2, and they are connected in this way. This is called AC tie line for the long distance. For long distance, this is actually being used for the controllability purposes. Okay, so that if one is failed, then supply can be maintained at the regular point or regular time. So there should not be there should not be any disturbances if if any fault condition arise in one of the power system. But what happens, same thing is happening in the when we are connecting the power system 1 and the power system 2. Now look at this point. The two neighboring areas are connected. I'm writing in the simple language here. The two neighboring areas can be interconnected, can be interconnected, can be interconnected. So these areas can coordinate with each other, coordinate and and perform, coordinate, they can coordinate, once again, coordinate and perform operation, or you can say the reliable operation, reliable operation. I hope up to this point you have understood. So coordinate, they can coordinate, okay, and they can perform the reliable operation. So these are the two power systems which are interconnected. Okay, now next point. But what are the problems, what are the problems which causes due to these AC lines? Okay, so one of the point is, so there are the problem or okay, once again, so one problem is the large power transmitted, large power transmitted, okay, because the high voltage lines are used for the transmitting the power for the longer distances. Okay, the large power transmitted may have the oscillations. But why these oscillations are occurring? Because you have the inductor and the capacitor, and these LC oscillations causes your high frequency oscillation. This LC circuit causes the high frequency of oscillations. Okay, so large power transmitter may have the oscillations, and that can lead to the frequent tripping. That is more important, you have to remember. Okay, this is oscillations, and these oscillations are occurring due to the LC circuit. Okay, that causes the oscillations, and these are high frequency oscillations and causes the frequent tripping. Okay, again and again there will be a tripping of the circuit breakers, or relay. Okay, so whatever the interrupting devices are connected in the power system for the protection purposes. Now next point I can add that, second point I can add that it increase it increases it increases in fault in fault levels. It can increase in the fault levels. The third point is most important here, the transmission. Transmission of disturbance that I've already talked in the previous slide. Disturbance from one and to other and using AC tri-line. Look at this picture. If at one power system, due to some faults, the disturbance causes, so that disturbance or oscillations can travel from this point to this point, and here there is another power system. So due to the disturbance in the power system may cause the disturbance in the power system too, or vice versa. Okay, so these are the 3 points I have written here. Now look at other points. So these are the conditions I have talked about, the problematic conditions in the AC tie line. So we are using the HVDC transmission lines. HVDC transmission lines. In the HVDC transmission lines, this is completely eliminated. HVDC transmission lines, these problems are eliminated. It happens, but I can write here the HVDC transmission line, there is the above 3 points are actually eliminated, but this is also occurring this is also occurring in the asynchronous DC lines. Asynchronous DC lines. So I can write no need to be coordinated. No need to be coordinated control. The control is not required. Control, one second, control. So the control is no need to be coordinated control, because it is more than enough. The whatever we are planning for connecting the PS1 and the PS2, the power system 1 and the power system 2, the same can be performed without connecting or without coordinating the power system in the HVDC transmission. Now, one thing you have to remember one thing remember one thing that two systems that remember one thing that these two systems okay guys, the two systems which have the different nominal voltage or nominal frequency, you can write the frequency cannot be interconnected directly. Okay, this you have to remember, cannot be interconnected directly with the AC lines. One thing you have to add, with AC lines and require the use of HVDC ties, HVDC lines or ties, links you can say. So two systems which have the different nominal frequency cannot be interconnected directly with the AC lines. Actually, in this way, we require the use of HVDC lines. So these are the some points I hope that you have understood up to these points, and thank you.